Now that we've practiced simplifying square roots with 7.3 part 1, we're going to use square roots to solve quadratic equations in 7.3 part 2. So we already know one way to solve a quadratic equation, which we learned in chapter 6, which is factoring. If I could spell the word right. There we go. Okay, so we're going to use that method to solve x squared minus 16 equals 0. So if you recall, if you have x squared minus 16 equals 0, then you factor x minus 4, x plus 4 equals 0. That means either x minus 4 is 0 or x plus 4 equals 0. This would mean x is 4 because you'd add 4 to both sides. Or, I went a little too far there. There you go. X equals negative 4, right? Because you'd subtract 4 from both sides. So there are your two solutions right there if you use factoring. Okay, now factoring is all well and good, but there is another method we can use. And it's taking the square root of both sides, the square root method, which we have down here. You isolate the perfect square on one side of the equation. Okay, so that means you're going to take your equation, and instead of having it set equal to 0, you're going to isolate your squared. So what you're going to do that is you're going to add 16 to both sides. Right? Okay, that'll give you x squared equals 16. All right, step 1 is done. We've isolated our square both sides. Then we be sure the other side of the equation has only a number, no variables. Definitely, right? We only have 16 over here, no variables in there. Step 3, we're going to take the square root of both sides, but remember to include both positive and negative square roots. And then we're going to solve. Okay, so we take the square root of both sides. So you take the square root over here and the square root over here. In fact, let me do that as the next step, just so that way you can keep them all straight. When I'm writing on paper, I would probably just put the square root symbol there in a different color. But okay, so that means that, and then what it said is make sure you include the plus or minus, right? Because when you take a square root, let me put it this way, x squared is 16. So that means that x could be positive 4 plus the square root of 16, or negative 4. We don't often write it that way, but that's what it is, right? The fast way to write that is x equals, and use the symbol plus or minus 4, right? Because positive 4, here, let me put it this way. Let positive 4 would work, right? Because if you square positive 4, that's 4 times 4, that's 16. And then negative 4 would work. Negative 4 times negative 4 is positive 16. So that's why it's really important that you include the plus or minus. Otherwise, you will not be correct. Right? It has to be there. All right, so we're done with that question. Let me box that. Hold on. There we go. All right, solved. So now we're going to use that method that we just learned there on that right-hand one to solve these equations. Now notice it gave you the right answers, which is great, but it helps because sometimes there are things that you can't factor clearly, or it would take a lot more work to factor it. So for example, this one is unfactorable. So let's find it. We have 3x squared plus 5 equals 80. Better double check that. Yep, that was it. Okay, so we are going to start by subtracting 5 from both sides. And that gives you 3x squared equals 75. Now you divide both sides by 3 because you're trying to get the squared part by itself. So you divide by 3 over here, divide by 3 over here. 3's divide away to make 1, right? So you're left with 1x squared over on the right, or over on the left-hand side, which is just x squared, equals 25. Then you take the square root of both sides. So take the square root here and the square root here. Actually, I'll make that its own step just to make it really clear. So square root both sides, if I could do that. There we go. Square root, plus or minus, don't forget it. right? Always, always, always. When you take the square root of both sides, you have to put plus or minus because it could be positive 5, because 5 times 5 is 25, or it could be negative 5, right? And you need them both. All right, there's our answer. Done. Okay, so that seems pretty simple enough. Let's use it for the one on the right. Okay, so let's see, 2x minus 1 squared. 2x minus 1 squared equals 49. Now the thing to remember is in that first step, it says to isolate the perfect square. Well, in these first two problems we did, the perfect square was x squared, no trouble. But in this one, the perfect squared is actually this whole side, which is already isolated, so even better. So we're actually just going to take the square root of both sides. So you're going to take the square root over here and the square root over here. And remember, whenever you do square root of both sides, plus or minus. That's true of any even root, actually. Square roots, fourth roots, sixth roots, so on. Okay, so over on the left, what's going to happen? Well, the square root and the squaring are inverse operations. So they unravel each other, and it leaves you 2x minus 1. For the same reason that over here, when I took the square root of x squared right there, it just gives me x. That's the definition of what a square root is, actually. Equals plus or minus, and then 7. Oh, okay. Now we have all numbers. So if that happens, you have to find, so note, all numbers, find both roots. There's a little note to ourselves. All right, so what are we going to do? Well, we're going to add 1 to both sides. Oh, you know what? You won't be able to do it that way. I take it back. Let's do it this way. 2x minus 1. 2x minus 1 equals negative 7. Or 2x minus 1 equals positive 7. So I'm splitting this up into two separate equations. That's how you're going to have to do this. So 2x minus 1 equals negative 7, or 2x minus 1 equals positive 7. All right, so now we add 1 to both sides. And I might as well do it to all the equations. So I did it to that one, and I'm going to do it to the one over here. There we go. Plus 1. Plus 1. All right, now what does that leave me with? That leaves me with 2x equals negative 6, because negative 7 plus 1 is negative 6, or 2x minus 1, or 2x equals 8. Then you divide both sides by 2, right? Divide by 2, divide by 2. X equals negative 3, or x equals 4. And there are both your results. So you have to find both results, right? You can't leave it like this up here with 2x minus 1 equals plus or minus 7. That's no good. So you have to separate it into two equations and solve both of them. Oops, I just had to move that over a little bit. All right, so we are done with that one. All right, so let's use the same technique, because it's not a bad technique, actually. And it's easier than factoring would have been, because you would have had to FOIL all this out and then bring the 49 over and all of that stuff. So let's keep using this technique over here for this one. So you have 8n cubed, or 8n squared, excuse me, 8n squared equals 3. So you divide both sides by 8. You'll have n squared equals 3/8, right? Because these disappear because you divide 8 divided by 8. Excuse me. There we go. All right, so now we want to take the square root of both sides. So the square root of n squared and the square root of 3/8 plus or minus, right? There we go. All right, so on the left, you're going to have n, no troubles, equals trouble. All right, so you're not allowed to leave it like this. This is terrible. So we're going to have to break this up a little bit. So this is plus or minus square root of 3 over the square root of 8. But you're not allowed to leave a square root of 8 in the denominator like that. So you're going to have to multiply by what it's going to take to make it turn into a perfect square. All right, so 8 is not a perfect square, but 8 is 4 times 2. So if I could turn it into 16, that would work great. So if I do 2 and 2, that'll make it so that n is plus or minus square root of 6 over the square root of 16. And the square root of 16 is a perfect square. So I'm multiplying by what it's going to take to turn 8 into a perfect square. So this is n is plus or minus square root of 6 over 4. And that is the right answer. Done. And I think we have time for one more in this video, and then I'll have to do the bottom two in the next one. So we have 2x minus 2, here. There we go. I was losing my mind there. All right, 2 times x, what was that? Plus 3 squared, take away 8 equals 100. Okay, so our first job is going to be to add 8 to both sides, right? You're trying to get the you're trying to isolate the square part. So I want that squared thing by itself. So I'm going to add 8 to both sides. That'll get me 2x plus 3 squared equals 108. Then I'm going to divide by 2, both sides. 2, divide by 2. The 2's will disappear over here because they divide away to 1. 2 divided by 2 is 1. So I'm going to have x plus 3 squared equals 54, right? And then now we want to take the square root of both sides, right? So we want to get the squared part by itself. So they're we're trying to get rid of the squaring essentially. So if you want to get rid of a squaring, use its inverse operation, which is the square root. So I'm going to take the square root over here. Let's see, plus or minus. All right, so this is x plus 3. Oops, x plus 3, there we go, equals plus or minus the square root of 54. All right, now let's take a moment and break down 54. 54 is 27 times 2. So that's 9 times 6, right? Okay, what I'm doing here is I'm practicing that, or I'm utilizing that technique we practiced way back here, which is to find a perfect square and break it out of the square root, right? So that's what I'm doing down here. There we are. Okay, so square root of 9 is 3. So this is x plus 3 equals plus or minus 3 square root 6. Now you just subtract 3 from both sides. Now 3 is not a like term with this whole plus or minus square root of 6 business. So what you're going to do is just write it. X equals minus 3 plus or minus 3 square root 6. And you're done. You can't combine them. They're not like terms. So you just have to leave it like that. Okay, we are all done with that problem. And I think that's where we should probably stop. And we'll come back here for the next one. See you then.